Welcome to The Explainer. Today, we are cracking the code on a topic that's, well, absolutely crucial for any developer: code coverage. We're asking a question that I think every single developer faces. How do you know your tests are actually effective? Because let's be real, it's not just about writing tests, it's about knowing exactly what they're covering. So here's our game plan. We're going to start with the basics of what code coverage even is. Then we'll dive deep into two key types: decision and condition. And finally, we'll see how this whole thing actually works in the real world. Okay, so what is code coverage? Honestly, the best way to think about it is as a vital sign, like a heartbeat monitor for the health of your test suite. It really just boils down to a percentage that tells you, hey, how much of your code did your tests actually run? This is a massive part of what we call white box testing, where we're basically peeking under the hood to see how the engine is really working. And as you can see, code coverage isn't just one single thing. Nope, there are different levels of rigor here, from the super simple stuff, like statement coverage, all the way to more complex types. For this explainer, we're going to laser focus on two of the big ones: decision and condition coverage. First up, let's talk about decision coverage. You might also hear this called branch coverage. And as the name kind of hints, it's all about the choices your code has to make. The goal here is pretty simple, actually. For every single if statement, every loop, basically any point where your code has to make a choice, we just need to make sure our tests run down both the true path and the false path at least one time. This is just a perfect way to picture it. Imagine you only test the path where you turn left. Well, you are completely in the dark about any potential disasters that might be waiting down the road if you turn right. Decision coverage makes sure you check both ways. Let's make this real with a super simple code example. So right here, we've got one decision point. Is the variable z greater than 100? That's our crossroads. Now to get 100% decision coverage here, believe it or not, we only need two tests. That's it. Our first test makes z greater than 100. Boom! That covers the true path. The second test makes z less than 100, and that covers the false path. Simple as that. Both branches are now covered. But what happens when our decisions get a little more complicated? Yeah, that's where the next level of testing comes in, and it's called condition coverage. You might also hear it called expression coverage. So here's the big change. We're not just looking at the final outcome of the decision anymore. Instead, we are zooming in and focusing on each individual little piece that makes up that decision. A great way to think about this is with holiday lights. We've all been there, right? With condition coverage, we're just checking if the whole string of lights turns on. But with condition coverage, we're testing every single bulb to make sure it can turn on and off. And that is so important because, one faulty bulb can mess up the whole thing. Let's check out a piece of code with what we call a compound condition. See that or in there? The whole decision is true if x equals 0 or if y equals 0. This is the perfect example of why condition coverage matters so much. We have two individual bulbs we need to test here. So if you look at this table, to get 100% condition coverage, we have to make sure that the x equals 0 part has been both true and false. And we have to do the exact same thing for the y equals 0 part. Our two test cases here pull that off perfectly, covering all four possibilities for the individual conditions. Okay, so now that we get the two types, let's see how they fit together. This isn't really about one being better than the other. It's about understanding the trade-offs and knowing what each type of coverage is actually built to do. And here it is. This is the key difference. Decision coverage, it just looks at the final outcome. It's efficient, for sure, but it can totally miss bugs that are hiding inside complex logic. Condition coverage is way more thorough because it tests every single piece of that logic. And that makes it so much better for catching those sneaky, tricky bugs in compound statements, reducing the risk that some subtle logic error gets out into the wild. And hey, if you need a handy way to remember the order of increasing rigor, I got you. From statement to decision to condition and all the way up to MCDC, which is an even tougher form of testing for things like safety-critical systems. Just remember this phrase: some developers cover more. So now that we get the theory, how does this all actually apply in the real world? Like day to day, what kind of coverage numbers should you really be aiming for? For a lot of projects, this 70 to 80% range is considered a pretty good target. It's a solid benchmark that tells you your testing is reasonably thorough, but it's also a little bit of a warning sign that, hey, there might be some gaps you need to look at. But, and this is a big but, while higher is usually better, chasing a perfect 100% score can be a total trap. It often means you end up writing tests for really trivial code just to make the number go up, without actually making your software any better or more reliable. And there are definitely a few common mistakes you want to avoid. It's super easy to confuse the different coverage types, to just blindly chase that 100% score, or to think this one number is the only thing that matters for quality. Just remember, code coverage is a tool to guide your testing. It is not a guarantee of quality. Really, the biggest takeaway here is that the goal isn't just about hitting some magic percentage. It's about having confidence that your code actually works the way you think it does, especially in the most critical parts. The metric is just a tool to help you build that confidence. So we'll leave you with this question to think about for your own projects. Are you just chasing a number? Or are you building real, justifiable confidence in your software? The answer to that question is what's really going to define your testing strategy.